Today's lesson is on similar triangles, SS 9.3. In this lesson, we will be studying similar triangles by building on your knowledge of similar polygons from the last lesson. The properties of similar triangles are useful for solving real-world problems. Identify and name the triangles in this diagram. Okay, so we actually have two triangles in this diagram. You have a smaller triangle, STR, and you have a larger triangle, PQR. Okay, and when you name triangles, you actually write a triangle symbol, and then you need three letters to describe that triangle. PQR would be the big one, and triangle RST would be the small one, RST. Okay? It doesn't matter what order you put the letters in. I could also name this triangle here, triangle SRT. That would still be the same triangle. Which are the corresponding angles in this triangle? Well, we have S corresponds to P. They're in the same position in the triangle. Angle T, which is a right triangle, corresponds to angle Q. And the third triangle, our third angle, R, corresponds to R. They're actually the same angle down here at the bottom corner. Angle R is actually in both triangles. How could you use what you know about similar polygons to tell if the two triangles are similar? Well, similar polygons, we know that the angles would be equal and that the sides would be in proportion. So that would be the same if we were talking about a triangle or a quadrilateral. Okay, what can we say about the ratios? Well, we could say that the scale factor would be equal. So we still have, our two triangles. So this is PQR, and this is STR. So the sides, ST, are going to be corresponding to PQ. And PR are going to correspond to SR. So it's similar, exactly what we figured out before with polynomials, but this time we're just using a triangle which has three sides instead of 4 or 5 sides. So QR, it corresponds to TR. Okay, if we could calculate, there is no numbers on here, but if we calculated the scale factor and they were equal, then we conclude that these two triangles are similar. So if the scale factor on each side is equal, then the two triangles are similar. Okay, so what our rule actually says, if two polygons are going to be similar, so when we have two polygons that are similar, okay, they have to be equal and the lengths, the corresponding sides, the measures of the corresponding angles have to be equal and the ratios of the sides have to be equal, or what we said before, in proportion, so the same scale factor. Okay? But a triangle is a special polygon. Okay? It's a special polygon. Okay? And what that means is that we have an OR in here. Okay? So a polygon, you have to have both the angles equal and the ratios in proportion. With a triangle, we can have the angles equal, or we could have the corresponding lengths in proportion. We can have one or the other. We don't have to have both. Okay? Just the way a triangle is made, if the angles are equal, then the sides will be in proportion. Or if the sides are equal, then are in proportion, then the angles will be equal. Okay, so we're going to take a look at this similar triangle. So angle P and angle S are going to be equal, angle Q and angle T are going to be equal, angle R and angle U are going to be equal, or we're going to find out that these sides are, the matching corresponding sides are in proportion. Okay, these triangles are similar because we have angle A and Q are both 75. Angle B and R are both 62, and angle C and P are both 43. We don't need to check the sides, we just know the angles. When we name the two similar triangles, we order the letters with the corresponding angles, the same as we did before. So A corresponds to Q, B corresponds to R, and C corresponds to P. When you look at those letters, that also tells you that AB, side AB, corresponds to side QR. So side AB corresponds to side QR. Okay? Side BC also corresponds to RP. So BC matches RP. Okay? And you can tell because 43 and 62 are the angles, 43 and 62 are the angles. So you can look at it that way. All right, decide if the pairs are similar and explain how you know. So we can look at this one and see if we have matching angles that are equal. So angle Q equals angle M, and they're both equal to 70 degrees. We have angle R equals angle H, because they're both 80 degrees, and we have angle P equals angle N, which equals 30 degrees. So we can say that triangle PQR is similar to triangle NMH. On the second triangle set pairs, we actually don't have any angles, but we do have side lengths. So we can look at UT and GH and compare those. So we have UT is 5/10, which is a half. We can look at ST and JH, ST and JH. So that would be 3/6, which is also scale factor of a half. And the third is SU and JG, which is 4/8, which is also a half. So because the sides are in proportion, then we can say that triangle SUT is similar to triangle JGH. Okay, identify the similar triangles in this question. Well, we need to be careful because we have to make sure that they are corresponding sides line up. So 4 is going to actually line up with 6. And we can do this in a couple ways. Okay, we can actually take this and rotate it so they're in line and the sides are corresponding. Okay, so we could put in the 4, RP was 5, and RQ was 6. Okay, so now we know that 6 and 4 are corresponding sides, 7.5 and 5 are corresponding, and 9 and 6 are corresponding. So let's see if we can figure out and see if the scale factor is the same. So we have QR matches RS. So we have 6/9, which is 2/3, or 0.6 repeating. RP matches RT, which is 5/7.5, and it's 0.6 repeating. We have QP corresponds to TS. So we have 4/6, which is 2/3, or 0.6 repeating. When we see that we have the same scale factor on all 3 corresponding sides, then we can say triangle RPQ is similar to triangle RTS. Now, you could also write it a little bit different. You could say triangle PQR is similar to triangle TSR. As long as the order doesn't matter, as long as the corresponding angles match. So P matches T. This second way I wrote it, P still matched angle T. Q matches S. Q matches S. So both of those are correct. Just like naming a triangle, doesn't matter what order you put the letters in. It does matter when you're saying they're corresponding that the two equal angles will be in the same position in your description of your triangle. Okay, so I'd like you to practice similar triangles. The second assignment on similar triangles, the similar triangles is second part of similar polygon assignments.